Okay, let's go over section 6.2, number 77, part A. Since I messed it up in my lecture today, all right? So part A, all right? So we want to find the absolute minimum value of this dn over dt, right? This function right there, all right? So first we're going to take the derivative. So let's not forget this negative sign here, right? Take the derivative of the derivative. So d over dt of dn over dt, right? So the shorter notation is second derivative of n with respect to t, right? All right, let's take the derivative. All right, so you have a constant negative 2000 is just a constant multiple, so I'll just put it outside. Negative 2000, right? Then take the derivative using the quotient rule, right? So square the bottom, so you have a quantity 1 plus t squared squared, right? Then derivative of the top is t, derivative of t is 1, right? Times the bottom quantity 1 plus t squared minus, right, top is t, multiplied by derivative of the bottom, which is going to be just 2t, right? Then simplify that, right? So you have a negative 2000 is there, right? Then you have, right, so 1 really doesn't do anything, so I'm going to just ignore that. And there's 1 here, right? So you have 1, right? Then you have positive t squared, and you have negative 2t squared. So combine them, we get a negative t squared, right? Then on the bottom, you would have quantity 1 plus t squared squared, right? Set that equal to 0, right? Which means that we can just simply set the numerator equal to 0. Right, negative 2000 is just a constant. I'm going to ignore that. And so we have to make sure that the 1 minus t squared, so that's the numerator. And I'm going to just go ahead and factor it out. 1 plus t times quantity 1 minus t, right? So we set that equal to 0. So we know that the critical numbers are t equals, from here, negative 1, and from here, positive 1, right? Since the interval is from 0 to 10, we're not going to consider negative 1, right? So positive 1 is the only critical number under consideration. All right, so we're going to just do evaluate the derivative of n with respect to t at t equals 0. So that's the left endpoint of the interval, right? But if you plug in 0 for t, the function is going to be 0 because 0 times anything is 0, divided by anything is 0. So I'm going to just go ahead and say this guy is 0. All right. And if you look at dn over dt, evaluated at t equals, say, 1. So that's the critical number right here, right? All right, so just plug it in. So you have a negative 2000. All right, times 1 is 2000 over. All right, 1 plus 1 squared is 2. So this is negative 1,000. All right. Then we look at another guy, which is dn over dt at t equals 10. All right, just plug in 10, so it's going to be negative 20,000, right, divided by, right, 1 plus 10,000, so 1 plus 10 squared, so it's going to be 101. So 101. All right. So this is going to be, all right. So this is about, let's say this is almost 100. So we are looking at looking around 2,000, well, let's see, 20, so 200. So you can see that this guy is actually larger than negative 1,000. All right. So we know that this guy is going to be our absolute minimum, because out of these three numbers, 0, negative 1,000, negative 20,000 over 100, it's around negative 200. So this is the smallest number. All right. So the minimum value of dn over dt is negative 1,000. All right. That's it. I hope that this was clear.